Hi and welcome. This project's going to be hopefully not too difficult. It is going to be to replace the manual Z-Axis feed with a power feed. I purchased an Asong power feed kit from All Industrial and we're going to install it, hopefully painlessly. The only problem that I foresee before this starts is the left side of my mill has the lockdowns, and so I really don't want the limit switch on this side because it'll kind of get in the way. On this side I have a Z-Axis DRO, and what I'm going to try and do is mount the limit switches on the DRO carriage. It's very stiff, and I will set it up so that that will be my limit stops. I don't think I can use what came with the kit, but hopefully I can modify it and make it work. That way it'll be dual purpose and I won't have extra wiring on the other side of my mill. So this is the package as I got it, minus the top being open, of course. There's the instructions and some styrofoam packing damaged in shipping, but none of the parts seem to have moved much, which is great. Everything did its job. I'm not going to use these rails, I believe, because those are the adjustable stops, and I don't really need adjustable stops on the Z-axis. I just need to be able to make sure it stops before it hits the end and damages the gears or the motor or both. The manual is, you know, typical for, unfortunately, this part of the world. Actually, it might be a little better in some regards because they do try and explain things in English and Chinese, and the English isn't terrible. The only problem is that the drawings are small and not obvious. So they also use the same manual for their X, Y, and Z installation. The Z installation is sort of an addendum in the back, sort of like an afterthought. Kind of funny. It's this section right here, and as you can see, it's pretty hard to read and make out what's what. They did do mechanical drawings, so hopefully we'll be able to figure it out. Alright, let's go on to the next step and see if we can install this guy. So the first step is to lose the handle. To remove this piece, which I guess on some of them are pretty tight, but this one it's always been loose. So not a problem, easy to take off. And like a lot of people, I think I never screwed my handle on because I constantly take it off because it's in the way. Next is to remove the dial and the dial lock nut, which is right here. I'll put those up top on the trays. There were two shims that came with the dial, and they were set to space the dial out from this guy, which is the bearing packing adjustment, and they spaced the dial out so that it didn't make contact. Next, this guy unscrews. I'm not sure what the name of that part is. Let's see if I can figure it out. Yeah, I don't really know. Okay, so next is to remove this guy. Unscrew it. Also stick that up there. Next I have to remove this flange, and it will be replaced by the flange from the kit. Just so you know, I've never done this before, and I haven't done it before we started this, so I am going to be figuring this out as we go. But looks like this guy will replace it because it has two screw holes to actually mount the servo motor drive itself, and I guess something has to put the preload on the bearings. I guess that'll be the replacement shaft. The next step will be to remove the three screws that hold the bearing loading plate in. Let's see, what do they call it? Stand. Huh. I don't really understand what that is, but we're going to remove it. Oh yeah, look at that. Oh, and it's aluminum. No kidding. So the one that they gave me is a replacement steel, so I think I'm stepping up in the world. As long as I've got this open, I might want to pack this with a little bit of molybdenum grease and see how that works. That might improve the lubrication long term. I don't know that there's really high pressure here, but the grease that's in there, it looks like it's functional, but nothing impressive. So the replacement shaft has shims on it, and it came with a spring-loaded end. I'm not quite sure what that's for. I guess we'll find out. And this castle nut style deal that locks in with the handle, unscrews. So I'm going to pull all that off. Oh, and it's got a new keyway. Okay, great. So I'm also going to pop the key out of the keyway because I think that will end up going on the new one. That is right there. So we'll save that key. And they're talking about this piece threading on here to preload the bearings. So I will, I'm going to add some grease and I'll be right back. By the way, just this is called the extension shaft, and I guess it's to extend this guy, make him longer so that we can fit the motor in there and still have the handle functional, because that is kind of key. We want the handle to still work when all this is said and done, because we don't want to be reliant on just manual, on power motion. We want to be able to manually raise the knee as well. All right, so let's put the extension shaft on. Okay, so next is to put on this flange, and the picture shows it oriented like so. So we'll try and reuse the existing screws. It also came with longer screws, it looks like. Not going to really refund these guys, but just get them snug. Okay, all seems good still. Okay. Next is to put the motor on itself on. The motor itself, I just banged it up, but it actually came with the bearings protected, which was a nice touch. Both sides, plastic sealed to keep moisture out. That's very cool. Okay, so now we need to get the screws that came with the kit. And inside this guy, let me slide this back out. Inside this guy, there are a lot of holes, so you can set multiple angles of this based on your piece of equipment or your preference. You could even mount it horizontally if you wanted. That's kind of nice too. Let me just double check the screw size here before I get that on. Make sure I get the right screws. Interesting. I know that I can change it. So let's start with horizontal, which seems like the obvious choice, but I'm thinking there's a possibility that maybe I would like it other than horizontal. So let's just try this and see how this works. So I grabbed myself a T-handle Allen, and that's working out a whole lot better. So it's in nice and solidly. So they also came with a spare key, which was a nice touch. So the first step, you're supposed to install this with the key not in, and here's the nice brass gear. So they came with small shims and large shims. Large shims are for the hand wheel. The smaller shims are to shim out the gear to get the gear lash properly, so to make sure that the gear meshing properly. So I'm starting with about half the shims. They all seem about the same thickness. When you tighten it, you shouldn't be able to tighten it so that you can't move it, because ultimately you are going to tighten this guy and lock it in place, and you don't want it to have the gears too tight. So let's see. I think that's still too tight. So far I don't have the key in yet. So So one thing I discovered while doing this, that if you put the motor either all the way down or all the way up, it'll be in gear middle is neutral, which would be off and normal, but you can tighten this gear when it's in the top or bottom, and then you can feel what it feels like when you put it in neutral. So you switch between, and that's still way too tight. I think it needs all the shims in my case. I've been playing with this for a while, so you pop it in gear, then you can untighten it. I've been playing with a variety of shims, and I think it really could use all, or maybe all but one. Let's see, let me try one under. There are some thin ones and some thick ones. I've got all the thick ones and most of the thin ones now. So let me pop this guy on again, see if we found it. I've been working on this a little while. You need to get it right, because eventually what you're gonna do is you have to drill a hole through this and put a pin. And if you're wrong, you'll never get it, it'll never be right again. So there it is in gear, pop it neutral. Yeah, see, I think it really needs all of them. That's really weird. Let me pop them all in, and to be honest, I'm not quite sure. I know that I want the gears to mesh, but I don't want them to bottom out. Too tight and the gears will wear themselves out. Too loose and they'll wear themselves out. So this is kind of a precarious problem. So when I get all of them in, oh, maybe that is too much, I'm not sure. Let me try a little more. So here's what I decided on after a lot of tries, and I don't know if I can give you good advice on this. I'll just tell you what I did. I added and subtracted gears, shims, over and over, and then felt the way the gear feels. When it's all the way in, you can feel the gears really sort of grinding against this, which probably is the wrong thing. And if you add all the shims, then it feels like there's a lot of slop, but it runs free. I think what I've decided on is 5 shims, and that seems to be the best balance, where you put it in gear, you tighten the guy down, you put it neutral, and then you run it so you're powering the gear directly. And that seems to feel the best. That's the best way I can describe it. I don't even know if it's the right answer, but it's what I'm going to go with. When it's tighter, you definitely feel like the gears are really kind of grinding, and I don't think that's what you want. So we're going to go with that and hope I'm right, because if I'm wrong, it's going to damage the gear or the motor, and it's going to suck. So they don't give very clear instructions. They just say adjust it till it's correct. That's really helpful. Anyways, we're going to go with that. So now what they say is I've got to pack this with grease, then turn this guy around and put the key back in. And once the key's in, then this guy will align with the key, and then we can see where we're at. All right, so the next step is to pop the key in. A little grease on the key I would think would be a good thing, just so it doesn't seize in there at some point. And let's see how we go here. Really snug fit. Wow, that is a really tight fit. So now the key's in. Just so you know, their extension shaft, their key slot, their key, I had to take to the Scotch-Brite wheel and buff the sides of this, because the key would not fit. It was way too tight. So that's a little disappointing. Oh, now this guy goes in with the key oriented, like so. And we pop this guy on. Oh, yeah, we can tighten it up and then remove it, because we still need to put the hand wheel back on. So let me get this guy cranked in. Oh, and it looks like in all of this, the screws have loosened. All right, so let's take this all off again and tighten the screws. So I was worried about cranking them too tight because, well, that is steel back there now and it wasn't before. But I was a little concerned anyways, so I didn't really push it. Add a little bit of grease to the keyway too. There we go. So set this guy in there again. So the moral of the story is to put it on, test fit over and over. And I think even when I'm done, okay, that's pretty smooth. Okay, that feels good. All right. Next step, put the hand wheel on and get those shims right. So just like before, it comes with a bunch of shims to space the hand wheel out so that it doesn't rub when you tighten it all the way down. That actually is pretty darn smooth. But let's see. It may not need any shims. Yeah, it really may not. There is a slight gap there already. I think I'm going to go with 0 shims on that. And we put the castle nut back on. So my bad, this guy's steel, not aluminum. That was insulting. And it was going to be steel on brass. So I put 1 shim in just to see what it's like, and it's definitely smoother that way. I also added a little bit of lube. So one more time, let's get the castle nut on here and give it a good tightening. And so when it's in neutral, I can still lift and raise and lower the knee just fine. Let's see how it goes when we go on power. So I figured out what the spring's for. It's so you can leave the handle on and then just push in to engage. I'm pretty sure I hate that feature, so we won't be doing that because I have a very limited space, and so I'm not going to leave the handle on, but that's what it's for, my best guess. So here's the guy in operation, and turbo and slow. So there's always been a kind of a tightness in the ways a little bit, and I think that's what it is. They might need adjusting, but this guy is struggling a little bit, but it does seem to be working. Dial's smooth. So next we got to go for the limit switch. So my original intention was to reuse some of the mounting bracketry that the scales are on for the stops, but then I thought more about it and realized that in order for the stop to engage, there has to be a pressure applied, and that may be enough to distort this slightly, and if you do, then the readings are going to change as you reach your limits, and I don't think that's a good idea, so I think they should be completely separate. So I'm going to have to go back to my other idea, which is to put the scales on the other side where the locks are. So one thing I'm going to do is I want to figure out what the motion, how far the table moves. So what I've done is I've taken the table all the way to the top, then I'm going to reach over, take a Sharpie, and I am going to mark a point. So this is as far up as it goes. Then I'm going to take the table all the way to the bottom and measure that and figure out where a halfway point is. So now with the table all the way down, I have marked a point that represents the bottom of the knee travel. So I know I've got over a foot. That's pretty impressive. And so I've got to find a location for these parts, the switch and the 2 stops, that will take advantage of this. Now for me, a lot of times they make the stops adjustable, but I don't really have any interest in adjustable. All I want is to make sure that I don't go off the ends and have the motor run into the end, because that would be bad. So we're going to set our stops for the maximum limits. So if you weren't aware, one of the good points of having a power drive on your knee, a motor drive on your knee, is that when you switch from a collet where the tool is pretty much flush with the surface maybe sticking out, you know, a few inches, and switch to, say, a drill chuck, which you do quite often, the drill chuck adds like another 3 or 4 inches plus the length of the drill bit plus clearance to get it in. Every turn of the handle, one 360-degree motion, is only 100,000ths or a 1/10 of an inch. So it's 10 rotations per inch. You can see how you're going to be doing like 40, 50 rotations every time you transition back and forth, which I've done a lot. So the power drive is going to be a godsend. At least it's going to save my arm. So let's get back to finding positions here and see what choices we have. So the kit comes with these spring-loaded stops, and the point of the spring-loaded stops, from my guess, is that when you reach the end of your travel, you want the switch to stop the motor before you actually reach the end. Then you can take the hand crank and go the last, say, 100,000ths, so you don't actually risk damaging anything. They have a lock nut and with a bolt and a area that's proud that's supposed to slide down these 2 channels, except that even back here where they haven't been crushed or sprung back closed, these do not fit. So these aren't particularly useful, and that's also if you're going to do a sliding stop, which I am not. So I'm going to figure out how to set these guys up to put them in one fixed place to stop the full range of motion, and to stop the carriage from moving when I still have like 100,000ths left on each side. That way I can manually bring it in. Alright, so I got the new limit switch put on the casting, sort of centered it between the 2 knee tightening adjustments, and now I just got to mount the 2 stops. I didn't show you all the drilling and tapping because it's kind of mundane and it's hard to get a camera in here because this is kind of close to a wall. I don't have a lot of room in my garage. So I got the bottom limit stop in, and again I stopped when the line was just above this one so that you still had a couple cranks to go, because this is spring loaded and it can still go the extra distance, but that way the motor will shut off and no chance of damaging it. It's going to do the same thing on the top. Notice I'm below the line where my limit is, and I will set the limit switch here engaged right here so that this guy is off. So here's the final setup. I still left the lines there. I'd like to do something a little nicer looking. I got to figure out how to do that so that I know when I'm at the limits of the knee travel. But right now the spring-loaded stops will stop at about a 1/4 inch shy or 250,000 shy of either limit, so that I can hand crank the rest of the way if I need to make it there, and there's no chance of the motor having to stall on the end of the travel. So anyways, there it is, and it was a useful project. I still need to drill through here and pin it, but I've been playing with these adjustments. I'm not sure that I exactly have it right, so I'm going to play a little more, and when I'm done, then I will drill through here and pin it. So here she is in action, coming up. About to reach the limit today. And it stops. And that's it. Thanks for watching. Hope to see you next time.